Good morning, and thank you all for joining us for our webinar today as we talk about the advanced functionalities of 3D Experience DELMIA Robot Programmer, a cutting-edge tool for designing, simulating, and optimizing robotic operations. Today, we are joined by Shubham, the Technical Manager for Lean Manufacturing at CAD Micro. Before I hand things over to Shubham to kick us off, there are a couple of quick housekeeping items to mention. First, as usual, we'll save a few minutes at the end of today's session for a question and answer period. Feel free to type your questions into the Q&A pop-up as they come up, and we'll do our best to get to them all at the end of today's webinar. The webinar will be recorded, and we'll be sending you the recording via email tomorrow. If any questions do arise afterwards, you can feel free to reach out to us and we'll be in touch shortly. A little bit about CAD Micro. We were founded in 1984 and are a 100% Canadian owned and operated company. We are present coast to coast across Canada with 6 offices. Our mission is to empower clients with advanced technologies to innovate and succeed. We offer solutions across 5 oceans: design automation software, advanced manufacturing solutions, advanced simulation software, 3D metrology and scanning technology, and professional services in AR, VR, and XR. All right, without further ado, I will pass things over to Shubham to get us started.
Thanks, Shreya, and thank you everyone for joining us at this webinar on mastering offline programming using DELMIA Robot Programmer. So the agenda for today includes introducing you to the role what robot programmer is, looking at some of the production challenges that industry is facing today, how this role helps you tackle these challenges, why this role is beneficial for you, and then getting into the demonstration of the software, of some of the features of the software. And at the end, as Shreya mentioned, we'll have some time for Q&A sessions. So please keep typing your questions in the questions window. So let's get started. Robot Programmer is an offline robot programming tool which is present on the 3DEXPERIENCE platform. It essentially allows you to build, simulate, validate, and program your robot work cells. And because it is present on the 3DEXPERIENCE platform, it provides all the collaboration tools between different teams and different stakeholders. Robots are the key drivers of automation in the manufacturing industries. But robot engineers face this huge task of validating their robot systems in order to avoid huge clashes, as well as an effective offline programming tool so as to keep the robots in production with low downtime. This is where Robot Programmer helps us tackle these challenges through continuous engineering, which means that you can program your robot in the offline mode even without disrupting your current production. If you have a product change, if you have a design change, you can build your work cells, simulate and create your robot programs without even affecting the current production. It allows us to validate your robot work cells early. So if you're looking for space utilization, reachability studies, validating your robot programs through simulation, you can do all those in the Robot Programmer app. It allows collaboration across different teams. So if you have different teams working on the same work product, all of them can collaborate on the 3DEXPERIENCE platform to achieve overall efficiency. And at the end, it decreases the time of creating your robot trajectories, thus improving the cycle time and improving the overall efficiency of your production. This role is beneficial for you because it is a one-stop solution for all your robot processes as well as all the brands of robots. So whether you are doing material handling, point-to-point process, welding, contouring, fabrication, if you have Fanuc robot, ABB, KUKA, Universal, or any other type of robots, it has a library of more than 2,000 robots. So all of those processes can be programmed right here, irrespective of the brand of the robot. If you're building your own tools and equipments to attach at the end of arm of the robot, you can design that tool, bring that in this software, create all the kinematics, add all the joints, joint limits, speed and acceleration, and simulate the behavior of the tool right here and see if it is working as expected. Whether it's a greenfield project or a brownfield project, whether you are creating a new robot work cell or replacing an existing robot, as you see in the video, where we are replacing the Fanuc with an ABB, you just need to upload your existing program. There is an out-of-the-box solution called controller synchronization, which allows you to synchronize the controller of both the robots, just optimize the trajectory and at the end, download the program in the ABB language. At the end, it allows digital continuity across different teams, right from product engineering, process engineering, robotics, and shop floor programmers. So because of this, you can achieve overall collaboration, which increases the overall production throughput. Let's start with the demonstration. In demonstration, we are going to build the work cell that we see in the picture. After that, we are going to attach the end tool on the and create a robot trajectory. We're going to create and simulate a robot task, and then we'll download this as a robot program in the native robot language. Because this app, this role is on the 3D Experience platform, I'm going to start by opening up my 3D Experience dashboard. This is my 3D Experience dashboard. Here you can see I have different tabs. One of them is Robot Programmer, where I can open and view the layouts that I have created. On the left, I have a layout with pick in place plus welding with universal and Finnick robot. On the right, I have a layout which is doing a dedicated arc welding. So you can see I have pretty big components like a battery pack and an auger and a Finnick robot, which is doing the arc welding operations. I have some other tools like 3D Lean, which allows me to conduct meeting and collaborate with my team, which has different boards like a sketchboard. I can track my KPIs. I have a PDF viewer. Also have an action log. If I open that action log, I can see all the actions assigned to me. This is the action for today where we have to create a robot cell and a program. I can also see the actions that I have completed and actions that are waiting and are planned for later this week. So let's get started with the action for today. So we are going to create a robot cell and program our robot. I'm going to click on the compass and open the Robot Programming Essentials app. This will launch my 3D Experience platform and open up the Robot Programming Essentials. Once I do that, this is my app open. So I'm going to start creating some of the components, which are basically part of my robot work cell. I will start by creating a manufacturing cell. So this is the parent cell, which is going to contain all the different components. This is for the organization purpose. I'm also going to create a machine tending plus a packaging manufacturing cell within this parent cell. So this machine tending will contain all the components required for doing the pick and place operation, like loading and unloading of the machine. And then the packaging cell will contain all the components which are required for the packaging of the machined part. Once I create a layout, I'm also going to create some more components. And once I'm done creating these components, I'm going to start importing 2D drawings. So irrespective of the CAD system you have, as long as it can export a 2D drawing, and if you have created a layout in your CAD system, you can import that 2D drawing right in the platform so that you have a reference of placing your components, your 3D components onto the layout. And because it converts your 2D drawing into the native file format as we see on the bottom right, it doesn't matter which CAD software you are using or what is the file format of the drawing. So I have imported my 2D layout, and as soon as I do that, I'm going to start bringing in the 3D models of this layout. I have a catalog from which I'm going to bring in a Haas Enshi machine. And I'm also going to bring a table which is going to act as base of the robot. So the robot is going to be mounted on this table. Right now, they are not placed exactly on the layout. So you can see in the catalog, I have different components as well, like conveyors, mobile robots, tools, which I can bring in into the layout. For now, we're going to start placing these components exactly on the 2D layout. And for that, we're going to use some of the smart layout tools present in the software. So I'm just going to change the coordinates of this. Right now it is sitting below the ground. I'm going to change the coordinate of z-axis and bring it exactly on the ground. And then I'm going to use the 3D handles, which comes in really handy to position the 3D model accurately on my 2D drawing. I'm going to do the same thing with the table as well. So I'm going to go again, select the table from the tree, click on snap, select one of the corners on the 3D model, and then select the corresponding corner on the 2D drawing. Now that I have positioned this component, I can import my robot. As I said previously, the Robot Programmer app comes with a robot library of almost 2000 plus robots. I'm going to bring in a universal robot in my layout. I open this robot. It comes with all the behaviors, joins, and commands which are already added to the robot. I'm going to import this in my original layout. So insert existing product. Now the last thing I need to do is mount this robot on top of the table. So for that, I'm going to use a tool called create attachment. Select the robot as a child entity, and then select the table as my parent entity. Then when I click on snap, it is going to snap exactly in the center of the table. So similarly, by using all these different tools and the catalogs and all the 3D models present, I can create a finished layout with conveyors and some of the storage devices and raw materials as well. You can see I have also imported a gripper, which is going to be mounted as end of the arm tool. Because it comes with a built-in kinematic wizard, I can open up this gripper in a separate app and add all the kinematics and ports required to mount this on the robot. So because this will be mounted on the robot, we need to define a base location of this. For that, I'm going to create a base port. There are different type of ports that you can create in order to simulate the behavior of this gripper. And then define a location of this port. I'm also going to create a tool center point, the TCP of the robot. This is also defined by a TCP port. And because of the intelligent data management system of the 3D Experience platform, any change that I make on an individual component, all of those changes will automatically be reflected in our main layout. So here are our ports. I'm going to go back to our main layout. Now I'm going to use a command called set tool, which is used to connect the behavior of our robot and the gripper. So here the gripper will be the child entity, robot will be the parent entity. It also defines the TCP of this profile. And then select the controller. I'm going to press OK. And when I go to the jog mechanism now, you'll see that I don't totally have the 6 joints of the robot to control, but I can even control the joints of the gripper, which are basically going to be used for opening and closing of gripper. So now that I have created the 3D layout, I have completed attached my tool to the robot. Let's get started with the robot programming. So the traditional robot programming method involves defining the 6 joints of the robot in order to reach a desired location, which is basically called forward kinematics. Here we are going to take advantage of inverse kinematics, where we are going to define a joint in Cartesian space, a position in Cartesian space, and all the 6 joints of the robot will be automatically calculated by the controller. These points desired location are called tag in this app. So now I'm going to start by creating a tag group. So this group is going to contain all of the desired location where I want the robot to move. I'm going to go ahead and create a new tag group, rename it, and start adding some of the desired points that I want the robot to move. So I'm going to say new tag. The first point is the top of the raw material, which is it is going to pick up and load it onto the machine. And simply click on the top of the raw material and just enter the coordinate system. This is based on the TCP port that we created, and press OK. I'm also going to create a couple more on the second raw material and then on the third one. Now, if I go to my jog mechanism, click on the robot, and then if I click on those tag points that I've created, you can see that all the 6 joints of the robot are controlled and automatically. There are different ways of creating these tags. One of them is using a TCP. So I'll first set this robot in home position, hide the machine. Because it is going to load the part onto the machine, we need to create a tag at that location as well. So I'll hide the machine. I'm going to go to my jog mechanism again, rotate and bring the robot to a desired location. Again, this 3D handles comes in very handy. I can easily manipulate the joints of the robot. And now, once it is at the desired location, I'm going to say apply and say new tag using the TCP. So where the tool center point of the robot is, exactly at that location, a new tag would be created. So this is how you can create different locations and take advantage of inverse kinematics in this tool. Once I have created all the desired location, I'm going to say generate a robot task. Click on the robot, select the tag group. So it will be the main points group. This is where we added all the locations. Just rename this as a load part. Press OK. So now in the device tasks, you can see that there is a task called load part. I'm going to open up the definition of this task. So this definition is basically the trajectory of the robot. You can see all the 6 points that we created as tags are added in this task. I'm going to delete some of the tags that are not required for this particular task of loading the part. And now I'm going to start adding all the positions required to complete this task. So the robot is going to start from its home position. So I'm going to add this home as the first position in the task. The second is going to be an approach location for the pick point. So I'll just use this 3D handles once again to lift it, translate it in a direction, and then add a tag position right there. So then from home, it is going to move to that approach position. Next is the load part, where it is going to pick the parts. I'm going to create a grab activity. And then once I do that, there is going to be a retract position from that point. So once it picks up the part, it has grabbed it, it will move to that location. I'm going to change the type of motion. So there are different types of motions involved. It can be a joint, circular, linear. I'm going to change this to linear motion. And now I'm going to go to the drop location. Because I've created a tag already there, you can see I already have that location defined. So I just need to add an approach point for the drop location. That point is added. Next is unloading on the machine. So I'm going to make sure the gripper is still closed. It is still closed. Add that as the final point. And after that, I'm going to create a release activity. So before we created a grab activity, now it is going to be a release. At this point, it is going to release the part. Now the gripper is open. A retract point after it has dropped the part. And then at the end, it is going to move to a wait location because it is going to wait for the machine to complete the machining process. Now that the robot trajectory is already created, I'm going to turn on clash detection. Again, go to the definition. So this is where I can detect if there are any clashes between the robot and the machine or the part or the raw material. This motion is okay. This is okay. Whenever there is a clash, that part will turn blue. There is a clash here because obviously the gripper is picking up the part, so we can ignore this clash. And it's going to go to grab the retract point, and then the drop point. So right there, I saw that the door turned blue, which is because when it is moving from the retract point to the drop point, the raw material is clashing with the door. So this is an excellent tool which allows me to do all the validation even before creating my final program. So I'm going to add an intermediate position in between so that to avoid that clash. So, and one more. Let's check all the motion once again. Perfect. I don't see any clash. So now our robot motions and trajectory is ready. Let's play the simulation. Perfect. So this is our load part task. Similarly, I can create an unload part as well as a packaging task for the second robot. And once all the tasks have been created, it's time to download the program in the universal robot language. So let's do that. In order to download the program in a native language, I need to import translators. This translator comes along with the software. So whenever you install the software, these are going to be installed automatically. Because I'm using a universal robot, I'm going to import universal translator. And once I do that, only thing I need to do is say create robot program, select the task for which you want to download the program. In our case, it will be all three. Press next. Let's check the mapping and again press next. So this is my robot program and universal robot language, which is .urp. Can again define the program right here as well. And press OK. So this is the end of the demonstration. As we saw that robot programming essentials app is a really beneficial app because it allows us to program any process and any robot and then download the program in its native language. Now we'll move on to the Q&A session.
The first one we have here is, do you have the option to add custom joint speeds?
Well, yes, you can create different motion profiles, accuracy profile, and edit joint speeds as well as motion type in order to simulate the exact behavior as you would see on the shop floor.
Okay, thanks, Shubham. The next one we have here is, can we use our existing CAD models into the layout?
Well, definitely yes. So as we imported the 2D drawing and all the 3D models, if you have CAD models for them, you can import them onto the platform. It will automatically convert your data in its native language, and then you have those layouts, not the 3D models in your layouts in the robot programming app.
Okay, thank you. The next one we have is, how does it handle multiple robo scenarios working on the same task or in the same area?
Well, if you have multiple robots performing the same task or even in sequence, it has an out-of-the-box solution which is called controller synchronization, which allows you to define and manage sequences as well as timing of those robots when they're performing the task and accurately simulate the behavior.
All right, that's about all we have time for today. If any questions do arise after we finish here, please do not hesitate to reach out to us or reply to the webinar email and we'll be in touch. Once again, thank you so much for a great presentation and thank you all for joining. We hope to see you again soon. Thank you.